We are going to talk about the second part of chapter 10.6, predicting outcomes. So let's go ahead and take a look at this statement here. Once we have an unbiased sample, like we talked about yesterday, and we collected that from a population, we can make a prediction about that entire population by setting up a proportion. And we're going to look at an example in a minute. Biased samples should never be used to make predictions, and we saw that yesterday. So bias samples cannot be used to make the predictions. They have to be unbiased samples. So here are the steps. We're going to be identifying the population, selecting a sample and a biased sample, of course, interpreting the data, and then making an inference or a prediction about that population. There's a couple of steps that we're going to go ahead and talk about in just a second. We're going to go ahead and take a look at problem number 5. It says a local middle school conducted a survey of randomly selected sixth graders to find which elective they were most likely to participate in. The results are showing in the table. So we have 14 students that took Spanish, 20 that took theater, and 6 that took art. We are asked for the first part how many students were surveyed. So in order to calculate this, we're going to have to add all of the number of students that took those elective classes. So 14 took Spanish, 20 took theater, and 6 took art. If we add those together, we get 40. So 40 students were surveyed. What percentage of students surveyed selected Spanish as their elective of choice? So now we're looking at just the Spanish students, or the students that took Spanish, rather. So I know that I have a total of 40 students, okay? So the total is 40. And out of those 40, 14 took Spanish. So it's really 14 out of 40. But we want a percentage. So we have to go ahead and be careful because this is a fraction, 14 out of 40. In order to turn a fraction into a percent, we must divide. 14 divided by 40. So I'm going to go ahead and show you the division here. 14 does not go into 40. Sorry, 40 does not go into 14. 40 goes into 143 times. 40 goes into 200 5 times. So I get a decimal as my answer, but we want to turn it into a percent. And we're going to talk a little bit more about this in a different unit. But for right now, know that in order to change a decimal into a percent, we have to take the decimal point and we move it to the right twice. Do the right to the right twice. So I have 35%. So 35% of these students in this sample took Spanish as their elective. Part C, the school estimates that there are actually 300 students in the sixth grade. Using this sample, predict how many students can be expected to sign up for art. So we know, based on this table, let's go back to the table, that 6 out of 40 students, so we have a total of 40 students again, and then 6 that took art. So we have 6 out of 40 from the sample, but now we're being asked to go ahead and predict how many out of the entire population, out of the entire school, which is 320 students, can be expected to sign up for art. So we're going to take the information that we have from this sample, which is 6 out of 40, and we're going to go ahead and calculate it by setting out a proportion to figure out how many students took art in out of the 320. So I know that we don't know how many took art, so we're going to put an X there, but we know that it's a total of 320 students, okay? So again, we're putting the total here. And out of the total, we don't know how many are going to be expected to take art from the entire population. So what we're going to do is we're going to go ahead and set this into a proportion, meaning 2 equal fractions, okay? And again, we're going to talk about a little bit further about proportions in a different unit, but for right now, just know that these 2 fractions are being set as a proportion. So these are equivalent fractions. And so what we do to go ahead and make this into equivalent fractions is we take a look at the denominator and we see 40 times what gave us 320. I could tell you that 40 times 8 is 320. Okay, so I did some mental math here. 40 times 8 is 320. And whatever I multiply at the bottom, I have to multiply at the top. So 6 times 8 is equal to 48. So 48 students will sign up for art. And these are the steps that that I was going to go ahead and come back to. Okay, so on part C, we went ahead and set up the probability as a ratio or fraction. We went ahead and used a variable for the unknown value. And then for the third step, we went ahead and find the missing value by making equivalent fractions. Equivalent fractions. We didn't use cross multiplication. We just used equivalent fractions. Okay. So letter D, a student claims that over half of the students at this middle school will select theater for their elective. So now we're talking about theater. So is this a true or false statement? So let's take a look at theater. There's 20 students from the sample, 20 out of the 40. Remember, 40 is the total number of students in the sample, and 20 is the number of students that took theater. So we want to know if that's over half of the students in this middle school, okay, based on this sample. So again, we're going to have to go ahead and figure out whether this is over half, and half would be about 50%. So we want to know if 20 out of 40 is in fact 50% or more, okay, or I'm sorry, over 50%, which is over 50% on the sample. So we're going to go ahead and divide 20 divided by 40 on here. And we see that we get 0.5 or 0.50. Again, we are going to turn that decimal into a percent by moving the decimal point to the right twice, and we get 50%. So 50% of our sample, okay, in our sample are going to be taking theater. So this statement is actually false because this student is claiming that over half of the students based on the sample will be taking theater. So if we use the information from the actual sample, we could see that it's exactly 50%, not over 50%. So the statement is false. Okay, so there you have it. This is part 2 of chapter 10.6.